Today we will discuss about the grid connected solar PV systems. So in the previous session we discussed about only without grid, where this is called off grid. So these systems are called as grid connected systems. The configurations or the diagrams what we discussed are off grid classifications. These are on grid classification. Here we are going to have the grid as an energy storage. So coming to the first classification, in this grid connected solar PV systems, we are having two configurations. First configuration is without the battery, so that what we have in our campus. Next system is with battery. Okay, let's try to see the major difference and the different components which are used in this grid connected solar PV systems. Coming here, already we know that we have to connect number of solar panels in series connection or parallel connection as per the requirement of voltage. So which is going to constitute the solar PV system. So output of a solar PV is nothing but what? Positive terminal and negative terminal. We are going to connect to an electronic circuit, electronic control unit, where this control unit now it is called as a grid connected inverter, but the components are same. Name we are changing. Why? Because we are calling it as inverter means input is DC, output we require as AC. Then which will perform DC to AC conversion? Inverter. That's why this is called with the name inverter. But this inverter is also called grid connected inverter, or this is also called a grid tied inverter. This inverter is tied to or is connected to grid. That's what is called grid connected inverter. Okay. So what are the inputs to this grid connected inverter? DC supply, and one more input is grid. Okay. So you see here, so we will have the number of solar panels, and from the solar array we are going to get positive terminal and negative terminal. So positive and negative terminal will be connected to the charge controller as well as to the MPPT. Already we discussed the importance of charge controller. It protects for example, if you have a battery, it protects the battery from overcharging and over discharge, and this MPPT will be used to consume the maximum power or to extract the maximum power from the solar panel. All this is once again connected to the grid. So from this output of the inverter, so this is DC supply. What is the output of an inverter? AC supply. From this AC supply, we are going to connect an intermediate component which is called net meter. The purpose of the net meter is, for example, we are generating extra power. That power will be exported. This power will be exported to the grid. For example, we are in deficient of energy. We want more units. Then this net meter will show you the amount of energy you have been imported. Okay, like this the calculation. Therefore, this meter will record the number of units that has been exported to the grid when you have in excess. When you are having a demand, or when you have beyond the consumption, then it is going to import. So this is going to export and import. Okay? Both it is going to perform, and it will show the difference, and that value is called net meter. For example, how to understand this grid connected system? Let's try to take an example. We have some, let's take our campus only. We have 150 kilowatt plant, and this plant per day will generate 5 units. Okay, so now what is this 150 into 5? How much? 750 kWh. So per day we are going to generate how many units? 750 units. For example, in the college we are going to have a consumption of 700 units. We will consume how many units? 700 minus 750 minus 700. We are consuming in our college. So how many units are extra? 50 units are extra. That 50 units we are going to export. So 50 kWh or 50 units we have been exported to the substation. For example, now it is which season is running? Summer season is running. We are generating only how many units? 750 units. But the load itself we are having how many units? 800 units. Why? Because everyone has run on the AC. So we are generating only 750. But extra how many you require? 750 minus 800. How much? 50 units extra you require. Then this 50 units you are going to import from the government, and you will pay the bill only for 50 units per day. Like this. This net meter will calculate how many number of units you have been exported in 30 days. How many number of units you have been imported in 30 days. So it will make the difference. For example, you exported both. Okay. Therefore, import minus export. You exported both, then you will get export in positive value, and they will pay how many units you have been exported into 5 rupees. Okay. Automatically you will get the revenue. Okay. That is how this meter is called net meter. It will calculate the exported units and it will calculate the number of imported units, and whichever is greater, who has to pay the bill, that will give the data. It's like a data logger. And what is the purpose of this grid connected inverter is it regulates the power with the help of charge controller, and it protects the battery from overcharging and over discharge, and it is used like a regulator, and it also functions like an maximum power point tracking, which is used to extract the maximum power from the solar panels, and this perform grid synchronization concept also. So here DC is given, but what is the type of output generated here? For example, this may generate 220 volts and this may generate only 49 Hz, but grid voltage is how much? 230 volts and 50 Hz. So there is a difference between 220 minus 230. This difference of this voltage will be taken care by this grid synchronization hardware. Okay, this grid synchronization software and hardware will be there. So this will perform grid synchronization, and this will nullify this difference, and by using a synchronization mechanism, and will make the grid voltage, the output of this grid connected inverter is also 230, and grid voltage is also 230, and it will try to adjust of its own, and it will get a difference of 1 Hz, and by using frequency synchronization concept, and this will try to make this 50 also as this 49 also as 50, therefore 50 minus 50 will become as 0. So this concept of adjusting the voltage by using reactive power, the concept of adjusting the frequency by using active power is called as a PQ control techniques. By using a software and hardware PQ control techniques, this will perform grid synchronization. Grid synchronization means generate the voltage from the solar panel which is exactly suitable to the grid voltages. If anything to be adjusted, then we are going to adjust the reactive power to get the required voltage, and we are going to adjust the active power to get the required amount of frequency. Okay, if you want to adjust the frequency, then you have to handle active power. If you want to adjust the voltage, then you have to handle reactive power. This is how to handle the two different components. Actually, reactive power is an instantaneous power. So this is used just only to transmit to the load, and in the negative cycle, the power what you have been transported will come back. Therefore, generally there is no reactive power in transmission line. Only which power is there? Active power. This is only the power which directly reaches to the consumer. You don't understand. So generally there is no reactive power. For sake of name only is there, but generally reactive power will go into the transmission line. So from the consumer, from the generating station, it will go to the consumer in positive cycle, and the negative cycle what it has been charged through inductor and capacitor, the negative cycle it will come back to the source. Like that, this is like a cycling process. Without reactive power, there is no transfer of again active power. So therefore, definitely you require a reactive power for the travel of active. This is an entirely different concept. So that is exactly understood by grid synchronization concept. So now the drawback with this system is here we can run this AC load. Okay, so here you are having an AC load with phase and neutral. So here this phase and neutral we are going to connect to an engineering college. This is our college. So here whenever there is no solar availability, then we will take the power from grid. We will take the power from the grid at night times. At morning time we will directly depend only on solar. If the main drawback of this system is if at the morning time the grid fails, automatically they will not power in our college. This is the main drawback of this system. Now, how to turn on this grid connected inverters? You need to have one more input to this grid connected system with the help of a diesel generator. With the help of diesel generator, you should turn on this grid connected inverter. Then only it can absorb this solar energy which is generated, and it will try to store in the, or it will try to make the load to be available. This is the main drawback of the system. If the grid fails, you require an extra source of diesel generator. Again, diesel generator is costly again. This is the main drawback. And generally, what are the applications of this grid connected solar PV system without batteries? A house. Actually, this government, central government has launched PM Garka Bijli Yojana. Okay, so PM Garka Bijli Yojana 2024. So through this scheme, all these concepts are explained. We are explaining all this concept through this scheme. And you see here, so PM means Pradhan Mantri, Gar means house, Bijli means current. Okay, so give power to the houses. Yojana means scheme 2024. They are trying to use this grid connected solar PV system without battery systems. All this PM Garka Bijli Yojana scheme is an off-grid system. It is an on-grid system but without battery. So coming to the next classification with battery, same configuration what I repeated here, same you are going to have. Here you are going to have a solar PV system with positive terminal and negative terminal connected to an grid connected inverter or an grid tied inverter, and output of this inverter is connected to an net meter. Net meter will take care about how many number of units has been exported, how many number of units has been imported, and from this net meter it is connected to the grid. So here what is the source of energy? I mean here we are generating solar power. There should be some source. The source is nothing. There should be some load. That load is nothing but the grid. Generally in the house also we use the inverter. So whenever the power is available, we will convert that AC to DC and we will store in the battery. But here what is the battery? What is the energy storage? Here the grid is the energy storage. So it can dynamically take the power and dynamically can give the power. Okay. So here already I told the problem is if the grid fails, we cannot make use of this solar power. If you want to make use of this solar power, again you have to connect this to a diesel generator, which is again costly. So you can overcome this problem by connecting this grid connected inverter to a battery system. Okay. So this is nothing but design the system with ampere hour rating as per your backup requirements. So therefore, whenever you connect to the grid, what are the inputs to this grid connected inverter? One is grid, next one is solar panel, and next input is from battery. For example, at morning time if the grid failed, what will happen? Already what is there is connected, battery is connected and load is connected here. Okay. So here you have the load. This is our college. So to our college what is connected? Load is connected, and this battery will try to discharge and will help the college load to run. Okay. And why we are not using in our campus? Why? Because this solar, this grid connected system with battery is very costly. For every 4 to 5 years you have to replace the new battery, so which is very costly, and it's like for every 4 to 5 years you have to change the battery, which will consume around 50 to 60 lakhs a day. So that's why we are not going with the battery system, we are going without battery system. And here this plant will be operated for how many hours? 24 hours. How many hours? 24 hours. And what are the application areas of this system is we can use in telephone towers. We are having this mobile towers, Geo, and we have different towers. All these towers use which technology? Grid connected system with battery. Why? Because they need to operate the tower 24 hours. It will be morning or night. 24 hours they have to be operated. Then they use it with battery grid connected system. Next one is hospitals. Almost all the hospital, why? Because patients will be there and surgeries will be continuously going on, and they require oxygen remaining. Why? Because if the patient is ICU, different multiple things to work. So definitely they require power. So for those kind of applications like 24/7, we require which type of system? Grid connected system with battery. So this is all about a grid solar PV system without battery and with battery. Next one we have. So to this system we connected a diesel generator. So to this system again you can connect a diesel generator or wind plant also. So how many inputs are there to this connected system? One is solar panel, next input is grid system, next input is wind plant, next input is diesel generator. More than 4 inputs are there. Where these systems are called multi sources system, or is called hybrid system. Here for this system how many inputs are there? Solar is one input, next input is from the grid, where grid acts as an energy storage. Here how many sources are there? Solar, grid, and next input is what? Battery. So for example, you want to connect one more source, like what you call wind energy. So then you can connect to wind energy, or you want to operate in whenever it fails also, then you can connect an diesel generator also. Okay. So therefore those systems are called as a hybrid grid connected solar PV system. This we will discuss in the coming sessions. Hope the concept is very clear. Okay. So all this is called the configuration or the way of connecting the diagram. So first is solar panel, and next one is grid connected inverter. Output of grid connected to net meter, and net meter is directly connected to the grid. So here the flow of power is in bidirectional. It can export the power or it can import the power. So here also same, but here it is with battery. So the battery means definitely this is a very costly system, and it is generally used in cell phone towers or mobile towers, or especially hospitals, high-end hospitals with 24/7 power supply is required. Then we can use this with battery configuration. This we can use without battery configuration. So this is everything about the grid connected solar PV system. The next session we will discuss about hybrid solar PV systems.